Okay, so I've been chatting a little with Chris Fox and with my people internally, and I'm trying to bring some stuff up while I'm talking to you, about, you know, we've had this long-standing problem of the DNS proxy in that home router or DNS forwarder, whatever you want to call it, and how to deal with that. And so we've been looking at more detail at the proposed discovery solutions, specifically with respect to when you've got this function in the home router. And of course, they upgraded my Firefox over the weekend, and now nothing works. Okay.
You've got the new version.
So I'm going to have to move over to my Microsoft. Let's see. I can't even remember what it's called. Edge. Yeah.
Edge.
Okay. Which I don't have all my logins information saved, but let's see if I can do this. This is so frustrating when you get upgraded without your.
Sounds like a downgrade.
Yeah, I had to like go and find my old profile to use it again. Anyway, so I've started a draft that tries to actually assess how well the discovery options work relative to this particular use case scenario, which was in the requirements. And so theoretically, it's something that, please forgive the grandson behind me. He's only 1 year old and he likes to bang at my door. Okay, now what is that? Okay, and it would appear that they do a really bad job. I mean, the current discovery mechanisms, I'm almost there, and I will share.
Hey, Barbara, Glenn here. Just to be clear, we're talking about what's in draft DDR when you say the current discovery mechanisms?
Well, there's DDR and DNR, and so it's kind of an assumption of where these two are heading, kind of based on some discussion and sort of what they do and what they don't do, and also looking at what's possible and looking at, in their current state, what they don't do, although there are some things they could do if they were made better. And so I can actually also send this as a link. I can find that chat window. So this is where I've started a draft. I hope this is appearing okay. And so I'm really concerned that it's not doing a good job. And this is something that's really sort of causing some consternation inside AT&T, because we understand that, what some of the reasons that we're using this proxy is its ability to provide the cache, which can reduce the load on the DNS recursive resolver up in the cloud. We use it to do a captive portal, and we are looking at changing over to the new captive portal architecture, which if I understand it, is supposed to be resilient against things like DOE, so that it doesn't really rely on the DNS. But we also look at things like the parental control. And you can provide a parental control up in the cloud, but it's not as good because you can't do it at the device level. Frequently you just want to target your kids' devices and not your own devices. And so just in looking at all of those, and local name resolution. So just in looking at these things, we're trying to understand, how can we really support sort of DOE and DOE discovery if we've got all these services that are going to break. And I don't know if people have any thoughts about any of this, especially vis-a-vis the fact that this specific use case was put in the requirements document, but it doesn't really seem to be supported at all. And one of the key problems is that, you know, doing DO to this little baby proxy, the mechanisms also don't allow for, well, it's unclear. It seems to be implementation specific as to whether or not they might trust any sort of self-signed certificate or anything like that. But short of that, it's really difficult to get a trust relationship built up and certificates accepted. But even that would require so much development in the home router that it's not clear what the use case, I mean, what the benefit is. So the whole thing is just, it's just leaving us like, which direction do we want to go? Do we want to support DO to the cloud natively? Because it doesn't really make sense to support DO out of the residential gateway. But if we do that, then we lose, you know, we can probably accept the fact that we're going to lose the caching proxy. That is what it is. But losing the local the local resolution and losing the parental controls and not having any way to really signal that don't upgrade to DO in these cases, or, you know, use a local resolver for certain domains. Because it's all being left up to the implementation as to how or whether they would do any of those things. That's making it just really difficult. So I'll stop there and ask, am I making sense at all?
Makes sense to me, but then I've read it before. I just wonder, Barbara, whether it would be worth just stepping through the 3 scenarios to give people a sense of, yeah, what they are and what the outcomes are for each of them.
Thanks. That's a good point. And you know, I wasn't prepared really to be going through this. And so, and by the way, I did have a meeting from 1 a.m. to 5 a.m. this morning, so I am not firing on all cylinders right now. Okay, so, you know, kind of some things that I figured were common. I figured that you'd probably, you know, in the future be able to assume that common operating systems are going to support both the DNR and the DDR, the 2 discovery mechanisms. Some applications, probably especially browsers, will support the DDR, the DNS-based discovery. And, you know, of course, no certificate authority is going to sign a certificate with a private IP address in the subject alt name field. I had to really explain that to a lot of my colleagues. It's like, no, that's not going to happen. Okay. And so, you know, kind of the first scenario I looked at was, okay, so if you have absolutely no changes to, and I used the RFC, oh, I can't even remember, the CE router is what I used. You know, you got to pick terminology. Okay. And I called it the DNS forwarder because that's what a lot of the terminology. Okay, so we've got the CE router, and we're assuming that it has this DNS forwarder and the DHCP and the RA capabilities, and none of this is being updated. And so there's not going to be any advertisement of encrypted servers. So you know, the DHCP-based mechanisms are sort of irrelevant. The DNS forwarder, you know, you can recommend all you want that the forwarder not forward these queries, but let's face it, it's going to forward these queries because it isn't updated. And that's probably going to be the mass of them. And so then the recursive resolver up in the sky, if it has that SVCB record, which we'd like to be able to put there, but it's going to provide that. And then whatever did the query, whether it's the operating system or the application, it'll determine that the IP address, they don't match. And so it won't use the encrypted resolver, and that's that. And so, well, that was not satisfying. Now, I haven't made any of the changes that Chris suggested yet, so I'll just step through the next one. And this one is sort of the next scenario where we do update the CE router to provide the information in the DHCP and the RA messages, so that you know, you can also not forward the resolver.arpa upstream. I really wish my. Okay. So, in this case, we will be able to provide some things downstream, but the applications that try the resolver ARPA will not do an upgrade because that's just going to fail. And presumably, in this case, the operating systems will use the encrypted resolver that's provided by DHCP. And that's just an assumption that that's probably where things are going to end up, because sort of some discussion on the list suggested that's what people would like, but we really haven't put that in any of the specs. But let's just assume that that's the way it goes. But some additional results that, you know, we're still going to see probably that local name resolution is broken. Now, I know that there are ways that it could not be, or it doesn't have to be broken, but because there's nothing going into any specifications anywhere, there's no best practices being written about, you know, how to do DOE in a way that doesn't break things. It's going to be hit and miss, and it'll be every operating system can do things their own way. Because of course we know that there are ways that the operating system could, you know, say, oh, well, I know I could, you know, go to this local DNS resolver for local domain names, but for everything else, I'll go up to my DOE server. But we have no reason to expect that there will be any consistency in such behavior, or that any particular operating system might behave in that way. And that's kind of unfortunate. The legacy captive portal is probably broken now, and that's unfortunate. And by the way, if you're curious as to what the captive portal is used for, it's really only used by us in the initial setup. That is when you first put this CE router, residential gateway as we call it, into the network. The captive portal recognizes that things are not set up, you know, the WAN connection, and so it actually helps get that set up and does all the detection so that, you know, this router is associated with this customer, and you know that it really is this customer, and so nobody can steal their service and things like that. And so the captive portal is just used for that initial setup, and that's a pretty important thing to have happen. And then there is the parental controls. There are still a lot of parental control services that are going through that router. And yes, we all understand that they are imperfect and they can be bypassed by children who know how to go searching for things on the internet. But nonetheless, some parents like them. And we do lose all of the local caching. Okay, so then the third scenario I stepped through is, okay, so let's say we update that CE router to support encryption to its DNS forwarder. So now it can provide DOS service or whatever directly from the CE router. You know, realistically, probably the best solution would be a self-signed certificate, because you can't provide any certificate that goes with the private IP address. And the public IP address is, you're not going to be able to sign those either, that the public IP address that's signed to the router. You know, there are some thoughts of other kind of kludgy ways that you might do things, but probably the self-signed certificate would be the most realistic thing to do. Except, of course, we have no reason to believe whether any particular operating system or application might accept it, and the ones that don't accept it won't use it. And the effort to do these upgrades is pretty big, so this really probably is not a realistic scenario. So that leaves us with, why the heck are we doing this? Okay, can I open it up now for discussion and what do others think? And by the way, you know, I'm just starting this out, and I first reached out to Chris, but I'm happy if anybody else wants to participate in this question and suggestions on where to take this, because it seems like, you know, and Glenn, you know, if you have advice, it doesn't seem like this is really necessarily the right place, but maybe it is the right place because it's an assessment of the proposals against the requirements, you know, to take it to the ADD working group. So let me stop there.
Fantastic. That's not bad if you were up in the early hours of the morning, Barbara, to do that off the cuff. I see Ralph has raised his hand, as has Glenn. So if we come to Ralph first and then Glenn, and then anyone else, either raise your hand using Zoom or put a question in the chat. We'll pick up on those. So Ralph.
Yeah, so Barbara, I think the option 3 always was what I envisioned as the sort of end game for CPEs. It is a lot of stuff to do, but it is the correct solution to kind of secure the connection from the client to the CPE and the additional connection from the CPE to the kind of ISP resolvers or what have you. And with that, you can provide all the required parental controls and what have you. Now, on regards to certificates, I mean, the current draft, it's the DNR or DDR, I can't remember which one's which, but it applies an opportunistic encryption for sort of RFC 1918 address that you can use. And going forward with V6, you actually could maybe provide a real certificate to a V6 address to actually authenticate that from a central DHCP server that also gives the IP addresses to the CPE. So I think that is the solution we should be aiming for. And of course, it requires, I mean, especially the parental control case, requires additional stuff on the CPE. You have to block IP addresses of external kind of resolvers because otherwise they'll be kind of reached. And I think Google recently proposed that they will do the initial lookup on the IP address of the resolver with HTTPS rather than doing a DNS lookup. So there has to be something on the CPE anyway. That's all.
Okay, thanks. Ralph, I don't know if Barbara or Chris had any thoughts on that before we'll move on to Glenn.
I'm not convinced about the certificates being possible because that you know, as static as the public IP address may be, it's still not static. It's not owned by that customer, and so that IP address it's still possible that it could be assigned to some other customer, and no certificate authority in their right mind would ever sign such a certificate. Not even you know, Let's Encrypt could, as I understand things, could sign such a thing like that. So and it apparently is a huge burden, and these boxes are cheap. Well, I mean, they're getting more expensive, but still.
And you still got to push out the certificate to the CPE anyway. So
And I mean, what I kind of prefer is if we could, you know, at least do something split, you know, like you have with a router having the default route and then specific routes. And, you know, if we could just have kind of specific domains in the default domain path, so that you could, encrypt all of your default domain lookups. But if you have local domains, and the captive portal, I think that the new captive portal architecture should be fine within the context of all of this DOE and such. So we need to upgrade to the new captive portal architecture anyway. And I think we're just going to have to, bite the bullet on the parental controls thing. But it, to me personally, the local domains are kind of a biggie, because that's something that I see more and more people really wanting to get to, as I see, more and more devices, as people are talking about having dozens and dozens now of devices inside their homes, being able to run local naming inside your homes it's really getting, I see it being pushed for more and more quarters. And I think having that local name resolution being split off from the network name resolution, and I think being able to simply do the DOE up to the network and having your local name resolution unencrypted may probably be the more logical solution. But that's just some of where I was thinking.
Well, we sort of have local naming with MDNS.
Yeah, we do sort of, but we also, yeah, it's what we're seeing is that with little IoT things having their own little gateways, we do see some additional little networks. And so we're looking at, things like the discovery proxy router that was defined in the DNS SD working group, where you really sort of need to start having some local domain name resolution that's not MDNS based, but is more DNS based. Maybe Glenn could talk. He's gonna. He wants to say
I was waiting for permission from our host, Andrew.
Well, I think carry on, Glenn. That feels like a good opportunity to come in.
Okay, I didn't want to jump the queue. Well, first, Barbara, very much thank you for taking the time to do this analysis and put it into words. I think this is a very, very valuable thing to have. So thank you. And if Chris also sounds like he did some contributions, thank you, Chris. So my first question will be, when are you going to publish this, the ADD working group, so we can start chewing through it? And before you answer that, I'd like to add that so as one of the co-chairs, we've been poking at the editors for both DNR and DDR a little bit, mostly DDR, for updates to come forth. Because I know there's been a lot of, if you've been following the pull requests, they've been very busy doing discussions and updating for future release. So hopefully, and I see Tommy Jensen's on the call, hopefully before AD meets, we can put this set of analysis together with the updated DDR draft, and maybe do a level set to say, okay, we've made progress in a particular direction. Are there things we need to like sort of step back, revisit a little bit, and retune before they get farther down the road based upon some of this analysis? So I guess that ended up being less of a question and more of a statement. But I will invite Tommy Jensen. Do you want to make any comments about how this might intersect with some of the updates we're going to be seeing soon in DDR? Oh, Tommy's having mic problems. Okay, then Barbara, when is this going to get posted to the ADD list so we can start poking at the current drafts with this analysis?
Well, I mean, I've given Chris editor rights to do any updates he think would be needed. And if anybody else would like to join in, and I can invite anybody. It's my GitHub. And so I could probably maybe post by end of week or
Okay,
start of
awesome.
Yeah, I was thinking to take a weekend when I was on leave last week, but I certainly should be able to make some updates this week.
Oh no, it's perfect timing because I'll be on vacation next week, so the whole firestorm can happen on lists while I'm away.
And I see Tommy's put that he hopes to have an updated draft out this week as well, fingers crossed. So it sounds like an excellent time for one of the co-chairs to go on holiday. I'm sure your fellow co-chairs delighted with the opportunity, Glenn.
Yes, Tail can handle everything while I'm gone. So the other comment I'll make is, you know, Barbara, I as well have worries, and this is without a hat on, except for like an adopter hat. I do have worries around the certificate management still, and I've been waiting for the drafts to mature so we can see where all that sort of settles down at. But I think you've rightly pointed out a concern I do have around the potential self-signed certificates and how we manage environments where we have things like private address spaces or spaces which are very non-static assignments. So thank you for calling that out. I think you really did hit the nail on the head right there.
Great, thanks, Glenn. I see John has his Zoom hand raised.
So actually kind of getting onto that question about certificates, it is actually a question and a comment at the same time. It seems like there's a fairly firm understanding that the certificates problem is one of the key issues to sort out here. And it seems to me that on a CPE basis, if we look at scenario 3, where the CPE or the CE, sorry, is designed to support encryption, would not, or did you consider in the analysis of this where the CE has a real IP address that it is serving DNS from, similar to an Anycast model where each CPE gets the same, whatever it is, /32 or /28 or whatever, that's an Anycast distribution, and then the CE simply fetches a certificate centrally. Now, I'm not saying that that's a good idea. I'm just saying that that's a possible idea for solving the self-signed certificate or the trying to sign private addresses problem. Was that in the consideration?
Internally, I'll say yes, but I'm not sure, you know, how to describe that externally. You know, it's kind of a weird thing of, you know, you basically, it would be something that presumably an ISP could do. It might be a little harder for somebody like a Netgear to do, because they often don't have a whole lot of IP addresses assigned to them, or, you know, especially Anycast type things. But, you know, certainly an ISP could take some number out of their lot and simply define it as an Anycast address that every single CE router can pick up on and have its, I guess, forwarder be attached to, and then you could have a certificate for basically that IP address that gets distributed to all of your routers. But that assumes, you know, well, that it's the ISP's router that is doing this, which in many cases it is, but also in many cases it's the Netgear router, and that really starts to complicate things.
And the other problem is how secure is that CE router against attack? And if we're handing out certificates to the router that says, here you are, this is something you can issue to prove that you are legitimately owning that Anycast address, that certificate that gets sent to my home router would also be valid for my neighbor's home router. And if I'm just speculating that presumably if I have some means of getting onto their network, I can then use that to leverage my attack. So it's not as simple as it might sound from a security perspective.
I didn't say it was a good idea, and I actually prefaced it with that.
Okay.
But it is a possible way of doing it, and it would be there are, I'm sure, a bunch of hackish ways you could divide that out in a number of other ways, but I don't think those are necessarily good. I'm just saying that it solves the problem of self-signed certificates or private IP address certificate issues.
I see.
And there are people working on this problem. So like Michael Richardson and Tiru, but they're not on this call.
Well, and they've been looking at it primarily more from an enterprise type perspective and a managed network perspective rather than sort of the home network, which is so near and dear to my heart. And to answer Paula Dare's chat question, no, I mean, and that's actually a scenario that I run in my house that you're describing about the situation with the CE device doing net behind the primary CE, because I do have a Netgear router that I use to firewall my ISP router. Unfortunately, I do so much design of my ISP router, I know very well what it's capable of, and so I firewall against it to my home network. So yeah, that is a common scenario, and it's something, you know, I could certainly, or anybody else, you know, I am happy to have other people contribute to this. It is, you know, I did it in the Markdown, so it's really easy to contribute to, and I'm happy to accept, you know, other people to contribute on this GitHub. And if you've never contributed on GitHub, I have a set of really simple instructions I can send, because you don't actually have to run Git on like your local computer. You can just directly use the GitHub edit mechanisms to directly edit the things and then directly create the pull request inside GitHub. So if anybody, you know, I know that these things can be intimidating for some people, but I'm happy to invite others to edit on this because it's really just something I'm trying to study.
Well, I'm just
So
scanning
send me
down the
an
list of
email with the
attendees.
GitHub account. Sorry?
So just scanning down the list of attendees. We've got quite a bunch of people from a wide range of organizations on the call. So I think there's some people here that could be well placed to contribute.
Yeah, so just drop me an email with your GitHub nomiker. Yeah, and I can certainly add you as a contributor.
Brilliant. I see Glenn has come back with a follow-up thought.
Yeah, well, it's a comment on the Anycast suggestion that with certificates. You know, that while I can see it sort of working, I would describe that as a hack because it ultimately, I think, undermines the trust relationships we're trying to establish in the first place with using those certificates, and probably opens a lot of scenarios. So, you know, my gut tells me that's a very bad idea, and I'm sure on some analysis I could come up with some really good reasons why it's a bad idea. But my gut really says that's a bad idea.
Agreed.
I can see. So I think you covered Paul's comment, didn't you, Barbara, on NAT behind the CE. Tommy, I'll read out Tommy's comment as he's having mic problems. Not to sound extreme, but if the constraints of the network are such that trust is required for many features to work between the CE and client devices, but secure mechanisms cannot be deployed, would it not be better to continue using unencrypted DNS on that leg and utilize encryption between the CE and the upstream recursive? Which I think is consistent with what you were suggesting, Barbara, I think. Right.
Well, no, what I was suggesting was sort of a split horizon type thing where you go directly to the recursive resolver for, you know, the default domains, but you go to your local resolver unencrypted for local things. But you know, and so here I'll just go out a little to explain that there is a significant amount of paranoia that exists, at least I can tell you in one ISP, there's a lot of paranoia that exists in the US, that there is concern that, you know, kind of the way Firefox decided, well, since you're not encrypting and we can tell you're not encrypting, we're simply going to go for it and, you know, go to Cloudflare and go elsewhere. And so there's a thought that if the local operating systems and clients and applications see that they're not using encrypted DNS, then they're simply going to bypass us.
I have another reason why Tommy's idea is, I don't think, the ideal outcome, which is that if we fast forward a few years and we have home networks with dozens of devices in, put together by users who are not particularly experts in networking technology, connected haphazardly, and some of those devices are not of the best security. It's clearly somewhere where it would be beneficial to have a more zero trust architecture, where we can still have encrypted DNS in the home to a device that we trust, and therefore prevent attacks from untrusted or compromised devices in that same home.
Yeah, I think most of those comments or attributes you described, Chris, probably described most home networks, to be fair.
Well, they're only going to get worse.
Yes. I see Tommy's put a follow-up comment about the approach being same provider based. So we're coming at it from a different direction, I think. And Glenn has commented or just questioned whether the CE devices will be capable of doing the TLS side of things at scale in the way described, which I guess is also worth thinking about. You've got to change out all the home routers, then you can solve the problem differently anyway. So it doesn't necessarily help. Right,
Yeah,
Paul and Ulrich.
I'll jump in, Andrew, and say there are millions upon millions of those cheap little monsters deployed, and we are not going to swap them out at scale. I mean, and I don't even mean like as an ISP, but like as a internet set of community people, that's just not going to happen.
Yeah, and I know from discussions before ITF, was it, I think 108, yeah, the sort of volumes involved would just be crazy. And even if you sent out free kit to people, you're going to rely on them changing out kit, which I think experience tells us a lot of people won't bother doing if they don't perceive it being broken. Then they just leave it in the box.
Well, I'm also left wondering about scenarios like where we have, ultimately people keep talking about having multiple pathways out of the home for, failover reliability. One might be a landline, one might be 5G. I'm not sure how some of these proposals would work in that environment either. And I will make an observation. The proponents of DOE, when it was first put together, were around privacy, and it seems like we're trying to add on security on top of privacy, and that we may be in a situation where we can have one or we can have the other, but we can't have both in this environment.
Yeah, often the challenge. Right, Paul and Ulrich have both been waiting patiently, and then there's some further comments in the chat which we'll come to. So Paul, do you want to jump in first?
Yes, just briefly, because I have a meeting coming up at the top of the hour. So we've had a problem with internet architecture, which is raising its head here. And so some of the tensions that Barbara's analysis is identifying here are actually old, and we may want to try to solve them here in a minor way, but I just want to contextualize them. So we've had a problem for, during the commercialization and privatization period, which began in the mid-90s, with networks being classified either as access or service, and the idea that both would occur as a customer of a single ISP is not well supported. Certainly Apple tried to do this with LLMNR, but in general, you can't find your own resources in your own network unless you can reach the core, the internet core. And that's a problem. We should have been working on that, but it doesn't make or save money. And so We have not been working on that. What we're seeing now is an extension of that. So this certificate problem, where you'd like to associate some kind of trust paths to reach local resources, runs afoul of the same problem. Trust comes from the core. And indeed, most of the browser operators are, in that mindset, and the operating system vendors likewise, which is that if you're not connected, there's nothing useful. And that's not true, as witness Barb's analysis. I recently had to sort of ignore a Golang module that spoke the SMTP protocol because it could only make outbound connections using SMTPS, and I wanted to talk to localhost. It's not possible to get a certificate for localhost. It is not reasonable to encrypt and decrypt data that is only transiting the loopback of my own operating system, because my kernel can already see what's going on in the memory images of both endpoints. So we are bedeviled by the fact that the internet has become a hub and spoke model, and we just don't have the type of support that we now need for what we're discussing. We don't have the support of being able to trust something locally, because all trust comes from the core. So this problem may be intractable, or it may be that we can carve out just the part of this problem that's affecting us and advance some kind of a solution and say, look, I know there's a big problem. We just want to solve the small problem that affects this one thing about local DNS. But I think a lot of people are going to say, look, it's not worth solving in the small case, and it cannot be solved in the large case. So let's find something that doesn't depend on that. So it's not a question, it's a comment. And I thank you for the chance to speak. And that's all. I got to go to the next meeting very shortly.
Thanks, Paul. In which case, Ulrich, do you want to jump on?
Yeah. Yes, I just wanted to ask a question here, and that is, I mean, the old devices will never speak though, right? I mean, that's just, they don't get updated, all this IoT stuff, they just speak whatever they speak now, and that's it. But the new devices, I mean, there is this new protocol called IPv6, and I mean, for example, a CPE could have a unique IPv6 range assigned, globally unique.
Great. So that's a fair question. And so I think you're posing, does IPv6 solve this?
Yeah, not solving. I
provide the basis for a solution.
Again, that goes to my point that even though most operators do try to avoid changing the prefix that's assigned to a customer, it's not guaranteed. We still reserve the right to move customers around among our for the telco operators, our BNGs and other things like that. And sometimes the IP addresses change. And then you also get the other thing that I see is the possibility. I really think of more hybrid connections where you may have a cellular backup to your wireline connection, in which case it's going to be different IP address space that's assigned from the different sides. And if one of the link sides goes down, it can get all wonky. So I just really think that that's not a tenable solution. And it's also not a solution for the Netgears of the world.
Okay, well, shock that IPv6 doesn't solve it. I think that's been said other places at other times. Let me just quickly scroll down the chat to bring us up to date. I'll skip over things which are just sort of self-evident comments. So Tommy has just I think pointed out that for Windows, it doesn't base its choice of resolver on whether the DNS is encrypted or not, unless the user specifies that's what they want. So if it's configured to use resolvers from DHCP or RA, then they'll do so whether it's encrypted or otherwise. So that's a helpful clarification. But Barbara then has gone on to point out that other operating systems, which apparently there are others available, may make different choices. But that's good to know for Windows at least. Yeah, Giampaolo, yeah, was rightly pointed out that where you got managed CPE, then that gives more scope for upgrading. But I do know from the stats from some of the big European operators that only a subset of their user base has managed CPE. That's probably true in other markets. I'll say that. That's probably not possible to contradict, because that must be true at least somewhere else in the world. That's a very safe assumption.
For part of the customer base, the CP is partially part of the core network, as is an element managed by the core and not under the control of the customer.
Right. Okay. Yeah.
Andrew, thank you for letting me steal your meeting. I appreciate it, but I have to go.
That's quite okay. Well, okay, let's draw a line there. I'll save the chat and share it. But well, thank you, Barbara, for jumping in. We can collectively wish Vinny well. Hopefully, he makes a speedy recovery, and I'll see if we can get him back on a call in due course. But yeah, you're right. We are out of time. So thanks everyone for coming on. I'll sort of share the chat with you so you can catch up with that, and upload the recording, because there's probably some of this you might want to go back over. We covered quite a lot of ground in a relatively short space of time. But don't forget,
if anybody, I'm sorry to interrupt, but if anybody does want to help contribute on this, just, again, drop me your GitHub moniker and I'll add you.
Perfect. Okay. Thank you, everyone. Don't forget, if you haven't already registered for ITF 111 and you want to, you can save $50 by doing so before 23:59 tonight. And other than that, have a great week, everyone, and we'll speak again same time next week. So thanks all for your time.